Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about chemistry of halogenated hydrocarbon CC6 Unit 1 Lecture 4. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So today we are going to talk about aryl halides, mainly preparation from diazonium salt, nucleophilic aromatic substitution, SNAR mechanism and Benzyne mechanism. So let's talk about aryl halides first. So this is the general formula of aryl halides. Benzene ring hyphen X. So this is C6H5 hyphen X. So where X equal to chlorine, bromine, iodine, fluorine. So this is called aromatic halide. Similarly, this one C6H5CH2X. So X equal to Cl, Br, I, F. So this is known as benzyl halide. Similarly, this X can be substituted at ortho position, meta position and para position. So this is known as orthochlorotoluene, metachlorotoluene and parachlorotoluene. Similarly, this one known as benzyl bromide. So first is preparation of aryl halide. So how can we prepare? So this benzene can react with chlorine in presence of Lewis acid AlCl3 giving rise to chlorobenzene. So benzene has pi bond. So pi bond can act as nucleophile. It would attack Cl and this Cl bond will break on this Cl atom, the CCl bond. So and it would attack to AlCl3. So that becomes AlCl4 minus. So again this AlCl4 minus will take this proton and this bond will break on here. So there will be revival of aromaticity. So that lead to the chlorobenzene. Similarly, nitrobenzene can react with bromine in presence of FeBr3 at 140 degrees Celsius. You can get this metabromo-nitrobenzene. Similarly, benzene can react with ICl giving rise to iodobenzene. Similarly, from diazonium salt we can prepare. So ArN2 plus X minus can react with HbF4 giving rise to ArN2 plus BF4 minus. And if we heat this compound ArN2 plus BF4 minus, we get ArF. So aryl fluoride plus nitrogen plus BF3. And next we can prepare from Hunsaker reaction. So silver salt of aromatic carboxylic acid can react with bromine giving rise to ArBr plus carbon dioxide plus AgBr. We can also prepare from phthalation reaction. So toluene can react with this thallium trifluoroacetate and potassium iodide. So we can get this iodo derivative. Similarly, benzoic acid can react with this thallium reagent and potassium iodide giving rise to orthoiodocarboxylic acid. So phthalation is almost exclusively para to alkyl R and halogen X and alkoxy substituents and almost exclusively ortho to COOH and COR. Then there is another commercial method for making chlorobenzene. So benzene can react with HCl and oxygen and COCl2 giving rise to chlorobenzene, that is called a Raschig process. Next is benzyl halide. So we can start from toluene in presence of chlorine and heat we can get benzyl chloride. So this chlorine can break in presence of heat giving rise to chlorine radical. Then the chlorine radical will abstract the hydrogen from toluene. So you can get benzyl radical. So again this benzyl radical will abstract chlorine radical from chlorine. So here it will be homolytic cleavage giving rise to benzyl chloride. Similarly, toluene can react with SO2Cl2 and in presence of peroxide giving rise to benzyl chloride plus sulfur dioxide plus HCl. So here you can see another mechanism. So TBuOCl. So in presence of peroxide also, or otherwise you can take TBuOCl. So at if you heat this at 50 degrees Celsius, you break this OCl bond giving rise to tertiary butoxide radical plus chlorine radical. So this would take this chlorine radical will abstract hydrogen radical from the toluene, so giving rise to benzyl radical which is resonance stabilized. So then this benzyl radical will abstract chlorine radical from SO2Cl2, so giving rise to this SO2Cl dot, and this would abstract chlorine from SO2 dot Cl, so giving rise to sulfur dioxide plus TbOCl again. Similarly, benzene can react with formaldehyde and HCl in presence of zinc chloride, giving rise to benzyl chloride plus water. So this formaldehyde can react with H plus, giving rise to this protonated species, so giving rise to CH2 plus OH. So then benzene pi bond would attack as nucleophile to CH2 plus. So as a result, you have this protonated species, carbocation species. So loss of proton will revive the aromaticity, giving rise to benzyl alcohol, which would react with HCl, giving rise to benzyl chloride. The next is nucleophilic substitution reaction. So of aromatic compounds. So simply aryl halides, unlike alkyl halide or benzyl halides, are relatively inert towards nucleophilic reagents. So except for very drastic conditions. So generally the aryl halides do not undergo nucleophilic substitution reaction as such, but under drastic conditions, so it will undergo nucleophilic aromatic substitution reaction. So here the chlorobenzene would react with sodium hydroxide. So here OH minus ion will be substituted under drastic condition 300 degree centigrade and pressure. So you get this phenol. Similarly, chlorobenzene with ammonia and 200 degree Celsius pressure and copper oxide catalyst. So you get aniline. Similarly, bromobenzene could react with COCN, copper cyanide, in presence of 200 degree Celsius pyridine. You get cyanobenzene. So electron withdrawing groups like NO, NO2, NR3+, CN, SO3H, COH, SCHO, COR present in ortho or para position, and the reaction is greatly facilitated. So here we can have this SNAR mechanism, so nucleophilic aromatic substitution, or we can call it bimolecular displacement mechanism. So substitution reactions involving relatively milder nucleophilic agents and active aryl halides containing electron withdrawing groups and ortho and para position. So here is the example. So this chlorobenzene is attached to electron withdrawing group nitro group at para position. So if you simply treat with 20% sodium hydroxide and 150 degrees Celsius, you end up with this OH minus will be substituted to aromatic ring, and it will kick out Cl as Cl minus. So here is the mechanism. So OH minus ion will act as a nucleophile, so it would attack this this carbon, and this pi bond will break on this carbon. So as a result, you get this C minus, and OH will be substituted here. So this C minus is resonance stabilized. So you can have you can draw so many resonating structures. So as a result, you can have this resonance hybrid. So once you end up with this carbanion, so this C minus will come back and it will kick out Cl as Cl minus. So as a result, you can have this nucleophile OH minus ion will be substituted plus Cl minus. So this facilitation is due to the intermediate that is more resonance stabilized. So here the resonance stabilized, if we don't have the electron withdrawing group, so the resonance stabilized is lesser extent, and here the resonance stabilization is a greater extent. So let's talk about aliphatic versus aromatic nucleophilic substitution. So generally in SN2 reaction what happens? So the incoming nucleophile will attack to the alkyl halide from backside. So what happens? You can have this pentavalent transition state. So here is the profile you can see, progress of reaction versus potential energy. But in case of aromatic nucleophilic substitution, you can have a transition state tetrahedral carbon. So ArCl OH minus. The next is Benzyne mechanism. So here is the example. So the reaction of a chlorobenzene with a highly basic amide ion NH2 minus in liquid ammonia. So this is chlorobenzene example. So that would react with sodamide in liquid ammonia, giving rise to aniline. So here is the mechanism. So NH2 minus, this lone pair will take this proton and this bond will move here. So as a result, you can have carbanion here. So when this C minus will come here, it would kick out Cl as Cl minus. So you can have this benzyne plus Cl minus. So in the next step, what would happen? So NH2 minus will attack to this one of the side of benzyne, and this pi bond will break on this carbon. So you can have this anion. So carbanion. So this carbanion would take the proton from ammonia, and this HN bond will break on NH2. So you can have aniline plus NH2 minus. So the nucleophilic substitution referred to as elimination and addition mechanism. So first step is elimination of HCl and second step is addition of ammonia. So if we have labeled chlorobenzene, so it would react with NH2 minus and ammonia, giving rise to this labeled benzyne, and you can have a mixture of these two products. Similarly, this para-substituted product can react with amide ion, giving rise to this benzyne, and further reaction with ammonia, giving rise to para and meta product. Similarly, this metabromoanisole can react with sodamide and ammonia, giving rise to this benzyne, and further reaction with ammonia, giving rise to meta-anisidine. So here you can see the structure of benzyne. So this is benzene ring, and here you have extra pi bond. So here you have poor overlap. So you can get this benzyne intermediate by trapping. So you can have this compound, and you can treat with lithium and mercury. So you can have benzyne, and if you react that in the reaction medium with furan, so you can have this product. Similarly, you can react to a chlorobenzene with methyl cyanide and sodamide and ammonia. You can have this benzyl cyanide. So this NH2 minus will take the proton from methyl cyanide. So you can have CH2 minus Cn. And since you have this chlorobenzene, so NH2 minus will take this proton, and this bond will move here, and this bond will break on chlorine. So you can have benzyne. So once you have benzyne, the CH2 minus will attack to this benzyne carbon, and this pi bond will break on this carbon. So you can have this carbanion. So once you get this carbanion, it would attack the ammonia molecule for H plus, and this bond will break on NH2. So you can have benzyl cyanide plus NH2 minus. So please subscribe to our channel Chemistry Live UGPG. So this is also available in the website www.chemistryliveugpg.com. For class 11th and 12th student, this is the channel Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you all for learning.